Welcome to our quantum deep dive. Yeah, today we're diving into something huge, a technology that could totally reshape how we all communicate. I mean, as a whole planet.
Seriously, just think about that for a second. What if your computer didn't just translate words, but got the feeling right? The humor, the emotion, the cultural subtext. A world where language isn't a wall, but a true bridge between people.
Okay, I know, it sounds like something straight out of sci-fi, right? But this is real. It's a field being explored right now called quantum machine translation. And for our deep dive today, we're going to be leaning heavily on a really fantastic essay on the subject by Jorg Ove Sneppad.
So, the big question is, how do we even get there? Well, here's our game plan for today. First, we're going to look at why today's AI is kind of hitting a wall. Then we'll do a quick and dirty primer on quantum computing. After that, we get to the really wild part. How on earth can this bizarre physics help us understand grammar and language? And finally, we'll get real about the road ahead and dream a little about what a world without language barriers could actually mean for us.
Right, that's the perfect place to kick things off. Because, before we can really grasp this massive leap forward, we've got to understand where we are right now and the very real walls our current tech is running into. Look, we've all used tools like Google Translate, right? And they're amazing, don't get me wrong. But they're also kind of clumsy sometimes. Schnepphad's essay points out a few big reasons why. First, context. They can lose the thread in long documents. An idea from the first paragraph is totally forgotten by the end. Then there's ambiguity. Is the word bank a river bank or a money bank? They just can't always tell. And maybe the biggest one, the sheer cost to train these models is just astronomical. It takes an unbelievable amount of power and resources.
And here's the thing. These aren't little bugs you can just patch.
Nope. These are fundamental problems that demand a completely new way of computing, which of course brings us to the main event, the weird, wonderful, and incredibly powerful world of quantum computing.
Okay, so your phone, your laptop, everything runs on bits. And a bit is just a simple switch. It's on or it's off, a 1 or a 0. That's it. But a quantum computer, it uses a qubit. And this is where your brain starts to melt a little. A qubit can be a 1, a 0, or, get this, both at the exact same time. This isn't just a minor tweak. It's a total game changer, letting it process a ton of information all at once in parallel, in a way that classical computers just can't. It's not even in the same league.
Yeah, that absolutely mind-bending trick is called superposition. And look, you can see the math on the screen, but let's forget that for a second. The easiest way to think about it is with a spinning coin, right? While it's spinning in the air, is it heads or tails? Well, it's kind of both. It's in a state of all possibilities. It's only when it lands, when you measure it, that it has to pick one. A qubit is basically that spinning coin, just holding way more information and potential than a simple on or off switch. And just when you think it can't get any weirder, it does. Let's talk about entanglement. This is where you can link two qubits together, so their fates are completely intertwined. I mean, if you check one and it's a 0, you know instantly that its partner is a 1, even if that partner is light years away. It's wild, but think about what that means for language. Remember that context problem? With entanglement, a quantum computer could connect the beginning of a document to the end instantly. No distance, no problem. Okay, so superposition, entanglement, these are incredible, almost magical ideas. But how do we get from a weird spinning quantum coin to actually translating a complex sentence? Like, what's the practical step? Let's connect those dots. And this is where the rubber really meets the road. Just look at that context row. We talked about how classical AI loses the plot in a long document, right? Well, entanglement could, in theory, create an instant link between the first chapter and the last. Just imagine an AI that can hold the entire context of a book in its head all at once. That's the kind of power we're talking about. Now, let's be super clear about something. We're not saying you're going to have a quantum laptop anytime soon. That's not how this is going to work. The real future here is a hybrid system. Think of it like a team. The classical computer does all the boring prep work, then it hands off the ridiculously hard part, the core processing, to a specialized quantum chip. Once the quantum chip is done, it hands the answer back to the classical computer to deliver the final translation. It's all about using the best tool for each part of the job. Okay, so this all sounds amazing, right? Like unbelievably promising. But time for a big reality check. We are at the very beginning of this whole thing. So let's talk about the long road from these cool ideas to something you can actually use. Yeah, the essay lays out a pretty long timeline. We're talking decades. Right now, we're in phase 1. These hybrid models are just starting to show up in research labs. Maybe by the 2030s, we'll see the first commercial applications of AI that get a boost from a quantum processor, but a fully quantum system doing the whole job, we're probably looking at 2040, maybe even later. This is definitely a marathon, not a sprint. And why is the timeline so long? Well, because there's a mountain of challenges to climb. For starters, qubits are unbelievably fragile. I mean, the tiniest vibration, the smallest change in temperature, and poof, they lose their special quantum state. That's called decoherence. And because they're so delicate, they make a lot of errors. On top of all that, we don't even have the right kind of data to train them with yet. And the computers themselves are insanely expensive and super rare. So yeah, big hurdles.
But let's dream for a second. Let's say we solve all that. We build the perfect quantum computer. We write the perfect code. What happens then? What kind of world does that create? And that really brings us to the biggest questions of all, the ones about society and ethics.
Well, the bright, shiny, optimistic version, which the essay talks about, is a world with just more understanding. The hope is that with truly perfect translation, we could have better diplomacy, scientists from all over the world could collaborate seamlessly, and we could all experience each other's cultures in a much deeper way. It's a really beautiful goal, for sure.
But, of course, there are some really tricky questions we have to answer along the way. Like, what about language diversity? If these systems are mostly trained on big languages like English or Mandarin, what happens to the thousands of smaller indigenous languages? Do they just get left behind? And then there's the elephant in the room, security. You see, the same quantum power that makes for perfect translation could also shatter the encryption that keeps all of our data safe online. These are huge problems that have to be solved right alongside the tech. Which really brings us to the final, central question, doesn't it? Is this the key that finally unlocks a truly connected world? Or is it just another powerful tool that ends up creating even deeper digital divides than the ones we already have?
You know, the potential is revolutionary, but the hurdles, both technical and ethical, are immense. It's going to be a fascinating journey to watch unfold.
And we really have to thank Jorgo Schneppet for his fantastic essay, Quantum Machine Translation. Our whole deep dive today was based on his incredibly comprehensive work.
Yeah, it was great stuff. And if you want to read more from him on this or other future-focused topics, you should definitely check out his website at schneppet.de. Thanks so much for joining us.
Take care.
Schneppet.de is a private project by Jorgo Schneppet dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.